Today we are going to talk about quadratic equations. Quadratic equations, and we shall learn how to solve for the roots of a quadratic equation. So what do we mean by these? So a quadratic equation is any equation of the form ax squared plus bx plus c, where a, b, c can belong to any real number. So what does this equation represent? What this equation represents, like if you write down a function, fx is ax squared plus bx c, and then we try and plot it. See, x, and we are plotting this function. It represents a parabola. And these points where fx equals to 0 are called roots of the quadratic. Okay. So let's draw a few diagrams first. Let's take the example that we did last slide. Let's choose a different color. So this was a parabola where we had two roots, root 1 and root 2. Now this is not the only parabola that can be drawn. We can draw a parabola like this, or indeed any other such parabola. Okay, now let's call these parabolas P2 and P3. You see that P2 and P3 do not intersect the real axis. What this means is that they have no real roots. So one thing that we'll try to do is to identify condition on A, B, and C. Remember, the parabola that we were trying to plot was this. We got a condition on A, B, and C, which gives real roots, right? So the first thing that we want to do is solve for the roots. So we set this thing equal to 0, and the method that we are going to imply is called completing square. What does that mean? That means that we'll take this parabola ax squared x plus c, and we'll convert it into something that looks like this. And where this thing is now a whole square. Okay, so how does this help us? This helps us in a very simple way. If we now set this thing equal to 0, we can easily solve this. For x. So how would you do that? You would just simply set x plus a prime whole square is minus c prime over a, and then you would say that x equals to minus a prime plus minus root over of minus c prime over c. Now, you can see that in the solution, if c prime is less than 0, then the solution is real. So that is what we are going to identify as a real criteria. Okay, so now let's go on and solve this thing. Let's first look at x squared and group terms together. C square is b x over a plus, let me write two terms, a prime minus a prime, and then add c. Now here I have basically added a 0, but this will later, or this in the next stage, will help me map this to a times x plus, so let's call this a prime square. Oh no, maybe not. Let's just keep it as a prime. X plus, let's call it b prime square plus something. Okay, so let's see what this means. So if we expand this bit, we'll get x squared to b prime x, b prime square plus whatever the constant terms were. Now we can compare this bit to this bit, and so comparing the marked bits, get x squared maps to x squared, so that's not a problem. The second term, x times b over a, maps to twice b prime x, and so we can get what b prime is from here. B prime will simply be b over twice a. And so now we have all the ingredients necessary to complete the square. Complete the square, we'll need to write down x squared plus b over a x plus, remember this was 2b prime x, and then b over twice a, so this is b prime square, and then we need to subtract it because that part was not there, and finally end it c. Write this out. Pull. This is what we shall get. So b squared over 4a is the part that comes out, and plus c. All right. So let's write that down again. We saw that ax squared bx c, it's mapped into a x plus b minus a whole square minus b squared over a c 0. Then we can simplify this. And this will then be equal to b squared minus 4ac over 4a. And then you can see it's this. Now, from here, you can immediately see that if b squared minus 4ac is greater than 0, we have real roots. We shall get this in another way later, but we'll get back to essentially the same criteria. We shall use calculus later to also figure out the same exact condition. So now we can solve the rest of the equation. X will then be equal to minus b over 2a plus minus square minus 4ac to a. That's that solution. One of the roots, R1, will be minus b plus b square minus 4ac over 2a, and the other root, R2, will be minus b minus b square minus 4ac. Okay. Okay, so let's look at this from the lens of differential calculus. What differential calculus tells us is that a curve, like a parabola, like this, has one point here where slope is equal to 0. This forms the minima or the maximum. Notice if it's the minima here, then basically it's the maxima for parabola like this. Okay. Now, let's go back to our equation. Fx is ax squared plus bx plus c, and let's insist that a, b, c are all positive, which would basically, so if you are calling this parabola 1 and if you're calling this parabola 2, this condition that a, b, and c are all positive means we are choosing parabola 1. We can do the same condition for parabola 2 with all of them are negative. So if you take the derivative df dx, that is twice ax plus b, and if we equate it to 0, see the solution x equals to minus 2a. Okay. Now if you take this solution x equals to minus b over 2a and plug back into fx equal to ax squared plus bx c, what you'll end up getting is that fx is equal to minus b squared minus 4ac over 4a. Now remember, our parabola is like this. So for a real root, we need that the minima here, basically we have a minima here, is less than 0, and that would mean minus b squared. So if you take this expression here, it would mean that minus b squared minus 4ac is less than 0. Remember, 4a, all of a, b, and c are greater than 0. So if that is the condition, that also means that square minus 4ac itself is greater than 0. And this was the same condition that we had derived earlier while completing the square. So today we have learned two things. We have firstly learned how to generically solve the roots of a quadratic equation, and then this is the solution. We have learned how to complete squares, and we have learned how to check real root criteria. That will be all for today. Thank you.